Hello, this is Dr. Oz. In our previous videos, we talked about introduction to linear programming. We developed a minimization and maximization problems. We solved them graphically as well as in solver. And we also covered sensitivity analysis. So now I would like to give more examples of applications of linear programming. Again, linear programming is very, very applicable in many settings. I would like to cover here a few more topics, but of course doesn't limit linear programming applications. I will cover investment portfolio selection model. I would like to talk about transportation planning and advertising campaign planning. So first of all, in this video, I will cover investment portfolio selection model. All right, so let's take a look at an example here. So there is a mutual fund called Welte or Welt, located in New York City, of course, right? And they're looking for investing $100,000. This could be million, it could be billion. This could have thousands of alternatives. Again, I'm just showing you a small example here. And let's say you are a financial analyst and you identified top 5 investment opportunities based on your extensive research. Maybe you spend months and years on this. And then you make projections using predictive analytics and data mining tools to come up with the projection for the future returns. So here are your projections for the future. You identify these 5 opportunities: 1, Atlantic oil; 2, Pacific oil; 3, Midwest steel; 4, Hubbard steel; and 5, government bonds. And your projection is this: you expect to have 7.3% return on Atlantic oil, 10.3% from Pacific oil, 6.4% per year Midwest steel, 7.5% annually Hubbard steel, and 4.5% for government bonds. Of course, you may say, hey, of course I will invest all my money here. Not necessarily, because you would like to diversify your portfolio, or you maybe manage pension fund that has certain requirements that you need to have certain amount of investment, certain industries, etc. So let's take a look at some of the conditions or constraints in this model. So one constraint is neither industry, oil or steel, should receive more than 50,000. So this is a less than or equal to constraint. Amount investment in government bonds should be at least 25%. I mean, government bonds are considered risk-free because basically governments can print money if they are borrowing money from their own currency. For example, US government can print, basically Fed can print US dollars if they need cash, or European Central Bank can print euros to pay their debt. So they're considered risk-free assets. And the investment Pacific oil is high return, but really high risk. So I don't want to spend so much money on that. So let's say not more than 60%, so less than or equal to constraint here. These are 3 constraints that are given here in this model. So let's talk about decision variables. Let's define decision variables. In this case, I have 5 decision alternatives. So I have 5 decision variables. If I had 100, I would have 100 decision variables. So first decision variable is dollars invested in Atlantic oil. Second decision variable here, dollar invested in Pacific oil. Third constraint here and decision variable here, dollar invested in Midwest steel. Fourth decision variable, dollar invested in Hubbard steel. And finally, dollar invested in government bonds. All right, so these are my 5 decision variables, and I'm trying to decide what. All right, so let's take a look at the objective. So objective is what? I have returns. So returns are something good. So I would like to maximize good things. Return for X1, X2, X3, X4, and x5. Let me write this, x2 right here. So I need, these are my decision variables. I need to multiply them with their coefficients. So from previous slide, I know these are my coefficients, right? 5 coefficients. So if I just enter them here, 0.073%, 7.3% times x1, right? Plus 10.3% for x2, so 0.103 times x2 plus 0.064, 6.4% return for x3 plus 0.075, 7.5% return for x4 plus 0.045, 4.5% for government bonds, x5, all right? So if I write all my constraints, again, this programs mathematical programs have 3 components in general: 1, decision variables; 2, objectives; and 3, the constraints. So let's write the constraints here. So constraint number 1 is x1 plus x2 plus x3 plus x4 plus x5 has to be $100,000. I'm assuming that I have to invest all my money. If I don't have to, it could be less than or equal. So this is kind of my budget. Constraint number 2, x1 plus x2 should be less than or equal to 50,000. Why? I don't want to invest more than $50,000 in one industry. Constraint number 3 is x3 plus x4 has to be less than or equal to 50,000 because I don't want to invest more than $50,000 into steel industry either. Constraint number 4 is I don't want to invest more than sorry. So let's talk about the let's look at the constraints again to make sure that we are on the same page. So let's see, what else do we have here? So we covered so far these constraints for oil and steel, and we need to talk about the government bonds. So it has to be at least 25% of the steel industry. Okay. So government bonds investment refers to X5 has to be greater than or equal to 25% of what? Steel industry, which is X3 plus X4. And constraint number 5 is, let's go back to our problem definition here. We are done with this. Oil company, Pacific Oil, is very high risk and high return, so it should be less than or equal to 60% of my portfolio. So how can I say that 60% of total oil industry? Sorry, not total portfolio, total oil industry. All right. So then, if I write this one down, my X2, which is the highest return, Pacific Oil, has to be less than or equal to 60% of oil industry investments, which is X1 plus X2. Perfect. And of course, I have non-negativity constraints, which means X1, X2, X3, X4, and X5 decision variables have to be greater than or equal to 0. All right, so these are my this is my model. Again, my objective is maximize, so coefficients of returns times the dollar invested. Decision variables are dollar invested in each alternative. I have 5 decision alternatives, and here are the constraints that I have. All right, so next video I will solve this problem with using Excel solver. Until then, enjoy business analytics.